Hello everyone. Today we are diving into a powerful technique used in programming and algorithms called divide and conquer. So stick around as we break it down with simple explanations and real world examples. So what exactly is divide and conquer? Well, it is a problem solving approach that works by breaking down a problem into sub problems and solving them independently and then combining their solutions to solve the original problem. So, let me explain it in three simple steps that are at the core of divide and conquer. First is divide. So, we break the problem down into the smaller sub problems, and these sub problems are usually of the same type as the original problem. And then the next step is conquer. We solve each of these smaller sub problems independently, and if the sub problems is small enough, it is solved directly. Otherwise, you repeat the divide and conquer process again and again. And then the last step is combine. Finally, we combine the solutions of the sub problems to form the solution of original problem.
So see here, divide and conquer strategy solves a problem by breaking it into sub-problems that are themselves smaller instances of the same type of problem. What does it mean? A bigger problems are divided into sub-problems in such a way that these smaller problems are similar to the main problems. That is why it is called the instances of the same problem. Okay, and then we recursively solve these smaller problems or the sub problems, and then at last we appropriately combine their answers. The real work is done in three different phases. First one is partitioning of problems, that is divide phase into sub-problems. At the very tail end of the recursion, when the sub-problems are so small that they are solved outright, means they are understood. Recursively solve the small problems, and in the combining together of partial problems or partial answers, we conquer it. So that is why when we are combining the problems or combining the solutions, this phase is known as conquer phase. These are held together and coordinated by the algorithm's core recursive structure. Okay, so let's see basics of divide and conquer. So the first one is recursion, then we have recurrence relation, and then we have recurrence relation solving. So what is this recursion? The process in which a function calls itself directly or indirectly is called recursion, and corresponding function is called as recursive function. So what is this now? Recurrence relation. So a recurrence relation is an equation or inequality that describes a function in terms of its values on smaller inputs. Okay, we have one example here. T of n is equal to T of n minus 1 plus 1. So you can see here that this T of n here is defined in terms of T of n minus 1. So suppose n is the number of input, here T is called for the number which is less than n. So this number, this when the function call is itself, this is calling the function t itself, but for the smaller input size. So that is why you can see that there is a recurrence relation between them, because this function is calling itself for the smaller input size. N minus 1 is smaller than n. Okay, so that is why it is known as recurrence relation. So Tn is defined in terms of T of n minus 1. Okay, so recurrence relation solving. So how do we solve these type of problems? So there are different methods. One is known as substitution method. One is known as substitution method. This one is substitution method. This method you might have done or used in your school when you are studying math. Okay, so let us see what is this. And then next we have iteration method. So we have these two methods of solving recurrence relation problems. So in iteration method, we have another different structures. One is known as recurrence tree method. One is known as recurrence tree method. Recurrence tree method means we have a tree-like structure like this. Okay, we have this structure. Okay, this type of structure. We'll discuss it later. Okay, so recurrence relations are solved. First one is substitution method, and then another is iteration method. And in iteration method, we can have recurrence tree method, as well as we have another method known as master method. So we'll discuss now just with substitution method, and the later and the others we will do later. So let us see some example. We'll understand with the help of some example what is this substitution method. Substitution means we have to substitute the values. We have to substitute the values. Or we have backward substitution method also. So in backward substitution, what we do, we substitute the values of the smaller inputs in terms of the given input. Okay. So suppose this is given as t of n is equal to t of n plus n minus 1 plus 1. Okay, so let me take another page. T of n is equal to t of n minus 1 plus 1, and t of 1 is given as 2. So what we can do, if you see this t of n minus 1, if I want to find this term t of n minus 1, what we have to do, we just put the n minus 1 in place of n. So what will be that? T of n minus 1 will be t of n minus 2 plus 2. How? We'll write n minus 1 minus 1. That will become n minus 2. Okay. So we can simply use this value of t of n minus 1, this value here in place of t of n minus 1. I can write here t of n minus 2 plus 2 plus 1. Plus 1 was already there. I have just used this one. Now t of n minus 2, if I find t of n minus 2, it will be, when I put n minus 2 here, so it will become n minus 2 minus 1 plus 1. So it will be t of n minus 3 plus 1. So we'll put here t of n minus 2 as a t of n minus 3 plus 1 plus 2 plus 1. It, so what it will become? T of n minus 2. Is there any mistake? Let me check. Okay, so there was a mistake. It was t of n minus 2 plus 1. This was plus 1. So this was plus 1. Okay. Now t of n minus 3. What it will be? T of n minus 3. Just put n minus 3 in place of n. So we'll get t of n minus 3 minus 1 plus 1. So this will be t of n minus 4 plus 1. So we'll put here t of n minus 4 plus 1, and there was already these three ones. So it will be, so you can see these are how many ones? 4 ones. Earlier it was 3 ones, and before that it was 2 ones. So you can just simply write t of n minus 4 plus 4. And when we keep finding this, you will see that the answer will be t of n minus, next time you will get n minus 5 plus 5. And as you go on, a time comes where you will subtract n minus 1, then here you will get n minus 1. Okay, and what will be the value of n minus 1? When you will open this bracket, you will find that it will become t of 1 plus n minus 1. And what t of 1 is given as, it is given as the value 2. Okay, so you just use this value. So 2 plus n minus 1. So what it is? N plus 1, because 2 minus 1 is 1. So this is your final answer. T of n is equal to n plus 1. Now when you are asked to find the complexity of this t of n, now you can write that it is order of n. It is order of n. Okay, this is all about today. We'll see more problems in the next class or in the next lecture. Thank you. Thank you so much.